Hi, thank you for joining me on this recorded level 200 session on migrations. My name is Martijn and I will be your guide towards application migration Nirvana, and I will be taking you through a lot of best practices and lessons learned from the planning stage of application migration that our customers are using in order to migrate somewhere. So there's a bunch of different aspects to this planning phase, a bunch of different products as well. So I will be mostly focusing on vRealize Network Insight and vRealize Operations. And everything that I will be talking about is already in the product. So I do have to show this disclaimer real quick. But again, everything that I'm about to show and about to talk about is already in the products themselves. So there's no roadmap or missing items yet. All right. Before I begin, also make sure to stay at the end of this session in order to get a QR code where you can get some pretty cool cloud management swag. But that's at the end. You can also fast forward, but hopefully you stay at the end. All right, so why are we here? Very quickly from the top to the bottom. The multi-cloud strategy that VMware has put out there for a couple of years now is actually taking hold. And I don't have to be so surprised about it because it's a really solid strategy and it's a very easy way for you to pick up a VM, put it somewhere else inside a public cloud environment and make your hybrid cloud a reality. So all of these destinations in the sense of migration are supported. We see a lot of customers actually making that move and also picking up their applications, VMs, and moving them towards those cloud providers. So this session is all about a little bit more deep dive. So I just wanted to set the scope of where you could do these migrations. But let's talk about the type of migrations first. So there's a scale of least effort, most efforts, and the amount of flexibility that you get. So when we start at the bottom left over here, we've got the device migration, which is just picking up your ESXi host and placing it somewhere else, and then spinning your workloads back up again over there. That's of course not an option if you go to a cloud provider because they have their own hardware. You're not allowed to put in your own hardware over there. But if you're moving data centers, this might be the most easy option that there is. You do need to have a very big maintenance window because you need to shut it down, pick it up, unrack, put it in your car, put it in a moving truck, and then move it towards the other data center and then spin everything back up once you've racked everything again. So that's very, very large time window that your entire organization is pretty much down. So that's why we don't really see that device migration happening a lot anymore. The middle one, the per network, is basically when you are migrating per network, per VLAN, per subnet, or per logical switch if you've got a virtual network. And that's the most easy one when it comes to the mid flexibility level. So in this case, you are basically just picking up the entire subnet and then moving it to your destination cloud. The reason why I'm saying it's mid flexibility is because you have to grab everything within that network, every single VM that's in that network, and move it all at once, or at least pretty quickly after one another, so you don't have to stretch those networks very often, or very long, I should say. So it gives you some flexibility in when you actually do those migrations and what type of migration schedule you have. And it's also the most common one that we see. It's a little bit 60% of a per network migration, and then 40% is per app. We don't see per device. And then the per app migration itself, that's where you got the most flexibility itself, because you can basically decide whenever you migrate a specific app. So you could, even if it's a mixed set of production or tests or staging applications within the same network, you could pick and choose which applications you migrate at that point in time. There's a couple of risks over there, because if you are migrating them with the IP addresses attached to them, so if you want to not re-IP your VMs, you have to extend those networks from the source towards the destination. That means that there's a lot of layer 2 network spanning going on, and you don't want to get that like very long in place. There's a couple of limitations that you need to take into account, which I will talk about a little bit later. But basically, you have to migrate, or you can create the entire migration schedule based on your application's needs instead of the network needs over here. So it's the most flexible, but it's also the most time consuming, because you have to do the entire discovery of your entire application landscape. And then also on a per application level, define like what is the migration window, when are we doing this, which applications are we bundling together, etc., etc. So these are pretty much the most common ones, the per app and the per network. And I will be referring to the per app quite a lot in this presentation, but know that everything that I'm showing you, so all of the planning scenarios, all of the data that I'm showing you is available on a per application basis, but also on a per networking basis. It's basically just changing the grouping of the data from an application onto a network. But again, I will get to that in the demos and the more specific slides first. So let's say your CIO Hector has decided that we are going to migrate towards the cloud, whether that be a VMware cloud on AWS or Azure or Google or just another data center. You've acquired another company and you need to bring in their data centers into your data center. So basically any type of migration at all where you want to pick up VMs, pick up applications, and then move it somewhere else. So the CIO hands that task over to the cloud admin, Wei, and Wei is left with a bunch of questions. So we don't know what kind of applications are running in the environment. I mean, the CMDB might be up to date. I don't know. They also don't have a clue on what type of workloads, what type of requirements, what type of performance do those workloads have currently, and what do they need with each other. So the dependencies between those applications is not clear. They need to plan out what we call migration waves, where you can put different applications or different networks into one group that you migrate at the same time, so in the same migration window, at the same weekend. So all of those questions need to be answered before Wei can actually make that plan. And it's typically divided up into these 5 steps. So we got the discovery phase, where we need to look at all of the applications within the environment and then map them out so we know what's running in there. We need to analyze the impact or performance of those applications. What do they need when they are taking from the source and going towards, migrated towards the destination? So how many CPU, memory, disk, networking traffic, packets per second, internet traffic, all of those things you need to know before you can make a valid assessment on whether it's going to fit at the destination site. Then, of course, when that analytics campaign is done, they need to invite the application owners in order to make sure that they have permission and they can inform the end users. They can make sure that the application works when they have successfully migrated it. So the validation phase is also there. Then step number 4 is actually running that migration. So making sure that you replicate the data from the source towards the destination. Make sure that all of the VMs are up and running on the other side. And then step number 5 is ongoing during the actual migration itself. So you need to monitor how the migration is going. You need to monitor if you're not by any chance hitting any maximums, whether that be in the data center interconnect or the the destination network. So if there's any limitations on the amount of traffic or the amount of packets that the destination network can send, you want to make sure that you really do not hit those maximums, so that monitoring and reporting is ongoing throughout the entire migration period. So let's drill down a little bit over there. So what does that actually mean? Those steps, how do we translate them into tasks? Well, first, the planning stage, which is going to be the focus of the most content in this presentation. So first, I already mentioned you need to discover the applications, and that could work via a bunch of different ways, but the most interesting way is using vRealize Network Insight in order to do application discovery based on the actual network traffic that goes through the network, and then linking them together, making that web of VMs basically visible. And then once you do have those applications discovered and saved in either your CMDB or in the vRealize products, you can start the analyzing process. So how many resources, how many CPU, memory, disk, and also IOPS and all the things, how many networking traffic, how many egress and ingress traffic is there, how many inter and intra application traffic is there. All of that information helps you understand how that application landscape is behaving and how much does it need in order to function. And we use vRealize Network Insight for that and vRealize Operations. So the networking side in VRNI and the compute side in VROps. Once that is done, then you start forming the migration groups, migration waves, as we call them, which is basically just groups of applications or networks that you group together and then migrate in the same maintenance window. And you do this because those groups will be interdependent, as much interdependent as you can get them, so that you basically have an isolated group of either networks or VMs, or I should say, hopefully the most isolated group, because they're never going to be entirely isolated, of course. And then move that all at once, so you do not overload the data center interconnect, for example, during the migration phase. I'm going to tell you a little bit about VMware HCX for that phase, because that's the pretty awesome tool that makes that migration possible. So it replicates data, you can even vMotion from one side to another. It makes sure that the networks are available on both sides. So there's a lot there. I'm going to tell you a little bit about it, but there are some different sessions within VMworld that tell you a lot about it. So I would definitely suggest joining any of those sessions. So after the actual migration, there's a couple other steps to optimize the environment. One of them is the security policies that you implement on the destination side. That could either be done before you actually start migrating or after, depending on what type of security policy you already have in place. Personally, I would opt not to do multiple things at once. So if you do not have a microsegmentation model in place on the source, do not do it during the actual migration, but either do it before you start migrating and then making sure that your applications are still okay, or do it like a week or 3 or 4 after the migration, so you are confident that the migration has been successful. The applications do not have degraded performance on the destination side. And then you can start adding more features into that environment to make it more secure. The optimization is also a pretty highly discussed step. You can either put that before you do the actual migration, making sure that that there's no unused capacity that you're migrating. So making sure that all of the VMs are actually active and not idle. Making sure that they don't have too much CPUs, vCPUs, or memory, or disk, or any other resource that they are consuming. Because if you are migrating that towards a cloud, you will start paying for it immediately. So the question is, do you do that before you do the migration? So in the planning phase, so after you've done the discovery, you will also see which workloads are active and idle. Then you can decide whether to do it on-prem or in the cloud. Personally, I would do it on-prem because it would cost you less if you do it on-prem instead of the cloud. The only downside over there is that if you do those right sizing, you're basically changing the configuration of those VMs, and you would need to let that settle down because you want to make sure that the performance, you have a very good baseline of the performance of those applications when you are moving them. Because if you right size them today and then migrate them tomorrow, and then the VM owners or the application owners come to you saying that the performance is degraded, what option or what step caused that, right? So you want to make sure that you have enough baseline over there to make sure that you have that performance baseline. So you can do that before or after. And again, there are tools and features within vRealize operations for that in order to make sure that you just can automate that reclamation. But I will talk to you more about that in another slide. So the secure apps step is done by vRealize Network Insight. You can grab the recommended microsegmentation rules from VNI based on the actual traffic that goes through the network. So you have a fair baseline of what types of firewall rules you would need. And then vRealize operations does the compute side of the right sizing. All right, so let's drill down a little bit further. So each time we go a little bit further. So first step, application discovery. Look at all of the applications on-prem, discover them using vRealize Network Insight with its flow-based application discovery. So you actually have a valid picture of your application landscape before you actually do start doing anything. So step number 2 is application dependency mapping, meaning that we look at what type of connections are going from application 1 to application 2 and how much traffic is exchanged between those applications in order to form those migration waves. Because once you have a clear view of those dependencies, you can group the most used applications together into those migration waves, meaning that you would have the most possible isolated group of applications in those migration waves. So ideally, there is no other connectivity towards other applications from one of these migration wave groups. How does this look in vRealize Network Insight? Well, basically, it's just a nested application. First, you discover those applications, then you have the application name and the tiers and the VMs inside there. And then you can group those applications into another application called a wave. Next step is to check what kind of requirements do we have. So what type of compute resources does this migration wave utilize? What type of networking resources does this migration wave need? How much egress traffic is coming out of this migration wave? If you're migrating towards the cloud, that egress traffic could be important. And just making sure that before you start any migration at all, you make sure that the destination can support the resources that you're putting into it by migrating this. And then the next step is to transfer those migration waves to VMware ACX. So I've already explained a little bit about VMware ACX, that it facilitates those migrations, and it has something called a mobility group, which is basically a group of VMs that it migrates at one go. So in this context, the mobility group is the migration wave because you migrate them all at once. There's a couple ways to get those migration waves or get those applications into the mobility groups within ACX. And I will show you a fling that I wrote that connects to the VNI APIs, gets all of the information about the applications, and then the migration wave is an application, and then pushes it towards VMware ACX. So you don't have to copy and paste anything over there. And then once that's done, you can actually start the migration, and you can pick between hot or cold migration. So do you want to do a replication, shut down the VM on the source, and then start the VM on the destination, start the replica basically? Or do you want to do a vMotion, so without any data loss? There are a couple of requirements that you would need, and the length of the migration is also different between those options. So look into those options. If you cannot afford any downtime at all, go for that hot migration, but make sure that you know and understand how long that will take. And ACX also has a prediction algorithm baked in, so you can actually predict how long a specific mobility group would take to migrate. And then once that's done, final step for this migration wave is the after migration check. So within both vRealize Operations and vRealize Network Insight, you can scroll back in time and see the behavior, see the performance of your VMs last week and this week. And then you can even compare them between one another, just to make sure that you see the same traffic patterns when it comes to networking, that there's no blocked traffic by the firewall rule set in the destination. So VRNI also logs the blocked traffic, and also making sure that you don't have any spikes, or if the disk I/O has been degraded, for example, in vRealize Operations compared to the destination compared to the source. So if you compare the timestamp from before migration and after migration, you can tell what the disk latency was before and what was it after. So you know that your performance is still okay, or maybe even improved. And then the last step is going around and around in a circle, because those migration waves, they tend to keep evolving, because if you do not get the okay from an application owner to migrate it, you pick up that application and take it out of the migration wave. But again, typically, like in a big enterprise environment, you would have a ton of migration waves. So you would have a ton of stages where you would migrate all kinds of different apps. So you would go round and round in a circle over there. So let's talk a little bit about the features that make this possible, starting with application discovery in vRealize Network Insight. Basically, it takes this web of communication network flows that happens within your environment and then makes sense of it. So it uses a machine learning algorithm. Oh, that was too quick. Uses a machine learning algorithm in order to identify connected components, connected VMs within your environment, sees what type of communication is there, how many sessions and how many flows are there, how much traffic is being pushed between those VMs. And then based off of that, it suggests a list of applications that are in your environment. So it looks first at an application boundary. So what would be an application? The 3-tier app, as an example over here, where we've got a web server, an app server, and database server. And ideally, those 3 tiers would communicate between one another. So that's how vRealize Network Insight knows that it would be one application. And then all of the VMs inside the same tier would behave the same and have the same port open, which means it can classify what type of tier it is. So it does this. Pretty much just presents you with a list of applications that it has been discovered. You can double check that, whether that's okay. You can see if there's any surprises for you. Maybe there's another tier on an application that was not known. We get that a lot. And then once that application discovery is done, it's saved into vRealize Network Insight, but then it's shared across all of the vRealize suite. So for example, vRealize Operations will receive those application constructs from vRealize Network Insight, and then you can do your requirements checks, your monitoring, everything that vRealize Operations does, monitoring, capacity planning, what if scenarios, all of that can be based on those applications. But the idea here is that you just discover it once via vRealize Network Insight, and then it flows into the other vRealize products like vRealize Operations. And that goes for both the raw applications. So if you do that application discovery, you have the individual applications. And then if you create those migration waves within vRealize Network Insight by looking at the dependencies, it would also sync those applications towards vRealize Operations. And that's important because we can then do that requirement check on a group level, migration wave level, instead of a individual level, and you don't have to group that manually, basically. So how does application dependency work? Well, vRealize Network Insight has a view of all what happens within the network, and it can draw that out in this donut shape. So basically, you can group by application, and then vRealize Network Insight will tell you which other applications are communicating with that application. And then even how much. So if you click either one of these lines in the donut, you would see the amount of traffic, the traffic rate, the packets per second, everything that's important to determine that application dependency. And then once you start doing that, you can dive deeper into the information, get a quick table of all of the types of communication that's happening. So physical, so are there any bare metal servers talking to this application? Is there any other internal IP ranges talking to this app? So end users, VDI users, everything that is talking within internal IP address to this app. And then also, of course, how much internet traffic is being consumed and sent by this application. So is it an internet-facing application? And if so, which countries are accessing this internet application? All of that can be answered by looking at the security planner within vRealize Network Insight, which gives you that dependency view. So when you have a good understanding of those dependencies, you basically just pick one app and then map it out to those other applications. You start to form those migration waves. So the migration waves is a group of those applications bundled together, which are dependent on each other, which you can see by that donut, right? So you can see how much traffic and if there is any other applications talking to this application. And then you build out that migration wave by putting in those dependent applications. In the end, and this is a very ideal scenario, but typically you would still have some other dependencies out there. But in the end, this is the ideal migration wave that you're looking at. It doesn't have any dependencies on any other application. It just has internet traffic, and then some shared services and other physical bare metal services that it's talking to. And again, if you look at either of these slices or either of these lines within the donut, you can tell what type of communication is going on, how much is it, does it concern me? So is it that much amount of traffic that it might not be feasible to migrate this over the data center interconnect? All of those things can be answered by looking at this. And if you then group by that application, you can select the migration wave as the focus point, and then get this view where you can see is that migration wave actually not dependent on anything else, or how much is it dependent on something else. Right, so we have those migration waves, but now we need to do the requirement check. So what happens if I migrate this migration wave, towards the destination? How much networking infrastructure do I need in order to support this? Well, there's a lot of data out there for that migration wave in vRealize Network Insight itself. You can group it together, make even pin boards, displaying all of that information in one go. But things to look into is how much north-south traffic is there, so how much internet traffic is there, how much east-west, so how much internal traffic is there, what is the maximum rate of the traffic, so the megabytes or megabits or gigabits even per second. What is the average rate and the maximum rate, so you can see the spike but also the average rate. And then I've already mentioned this per country slide, but if it's an internet-facing application inside the migration wave, where in the world do you put it if you are migrating to a public cloud? So do you put it in Americas, in the EMEA, or in the APJs? And then you can even dive deeper into the actual patterns of those applications within the migration wave. I like to create a pinboard out of these migration waves, so you have all of the information at one point in one page. And the cool part about that is because on a pinboard within vRealize Network Insight, you can also scroll back in time. So the pre and post migration check, which I mentioned in the process, you can make that a lot easier for the entire migration group this way. So networking now is done. You have the right information. It's all good, and you can migrate with a clear conscience. But then, what about the resources? So this is where vRealize the vRealize operations comes in, and you can run a what-if scenario against that migration wave. Meaning that application that you formulated within vRealize goes into VROps, and then you can run the what-if scenario, the migration scenario, based off of that migration wave application. It will tell you how much CPU, memory, disk you need, and also even how much it's going to cost if you are going to migrate towards VMware Cloud and AWS, for example, in this case. So how many hosts do you need in the destination to support it? You can enter information like how much room do I want to leave empty for any resource spike? So how much of a buffer do I want to get? And then according to that calculation and the migration wave resource that you would need, you basically just get a very nice report saying, all right, so you need to add 4 hosts in this case. It will consume this amount of CPU and memory, and it's going to cost this much. So that's like the entire business case right over there. And you can absolutely make sure that you have enough resources before you start migrating using this what-if scenario. vRealize Operations also has a right-sizing module or a reclamation option where you can look at all of the VMs inside those migration waves, see which ones are idle. Like, are there any VMs that are maybe 1% CPU and are completely idling? They're using 1% CPU, but they've got 16 vCPUs, for example. They've got 32 gigs of RAM, but they're only using 4 gigs. They've got a 2 terabyte disk, but there's only 100 gigs in use. All of those things are visible within that cloud management assessment, as we call it. And then you can even go as far as, from vRealize Operations, you can right-click or checkbox all of the VMs at once, and then hit reclamation or reclaim these resources. So it'll make sure that there's still a buffer available for the VM to spike for its resources, but it will just lower the amount of vCPUs, memory, or disk whenever there are idle VMs. And again, it's the well-discussed point whether you do this on the planning phase, so pre-migration, so you can save costs on the provider hosting cost, or you do it after the migration because you're basically in a hurry to migrate everything. So you can decide on your own, like, when do you want to do this, but do it. I mean, if you are migrating to a public cloud, you're basically paying for unused resources if you don't do this. All right, so then we come to the migration phase itself. So we're done planning. We know what type of performance we need. We know what type of VMs are going over that migration. And now we have those migration waves and we want to transfer them towards VMware ACX in order to make those mobility groups and start the migrations or schedule them. So, cool thing. The so-called vRealize Network Insight Toolkit is a Fling, a VMware Fling, and the link will be at the end, which is basically just an appliance. You can deploy it into your environment. You can connect it to vRealize Network Insight. And then there's a VMware ACX integration available. So what it does, it loads all of the applications from vRealize Network Insight. You can select multiple or just a single application from there. So you can select your migration waves from there. And then you can connect them towards VMware ACX in order to create the mobility groups from those VMs, from those VRNI applications. So imagine those migration waves could have a lot of VMs, and otherwise you would need to copy and paste them. And whenever there's copy and pasting involved, there is error and error margin involved. There's still human involved. So you actually want to automate that entire process and make sure that you get everything in one go. So this Fling, this toolkit will help you do that. It'll just connect to ACX, create a mobility group within with those VMs that you've selected. And then within VMware ACX itself, you can start configuring that mobility group. You can do the destination, the type of migration, all of that. And then basically start your migration. So again, VMware ACX is the tooling that we use, that our customers use for those migrations. There are some very good sessions, high level, but also deep dive on ACX at VMworld. So definitely check it out. Yeah. Once you've done that migration, it's time for the after migration check. And again, it's the same type of thing that you did with the planning phase. So you're looking at the traffic patterns, you are looking at the resource consumption, you are looking at the contention of the VMs that you've migrated, and then comparing that with the time window before the migration. So in vRealize Network Insight and vRealize Operations, you can select the date when you want to see those performance numbers and those application dependencies. All of that is available within that time window selector, basically. And then you can double check whether the performance has basically not been degraded, or maybe it's been optimized by that application. So during that after migration check, you also migrate or monitor the actual migration itself. So vRealize Network Insight, for example, with the screenshot that I'm showing right here, that is looking at the network topology between the destination and the source, or the other way around. So you have a full visibility on the network delivering the connectivity from your on-prem cloud towards your hybrid cloud or public cloud. So I've already kind of mentioned this, but this is a screenshot where we show vRealize Operations showing actually that pre and post migration comparison. And in this case, you can actually see this VM that has been highlighted has received a much better disk latency after the migration. So the thing to look out for here, and it also marks that in yellow or in red, is those degraded performance that I've been talking about. vRealize Operations makes it really easy to show that the status of its performance of those VMs by just color coding it. And just by doing this side-by-side comparison, you have a very good way to see what type of impact has that migration had. Has the old environment versus the new environment have on my VMs. And if there's any degradations there, you can start investigating using vRealize operations, looking at in the disk latency case, looking at the data store that is supporting that VM. Maybe that's overloaded, maybe that's having errors, but vRealize operations will show you that. And then once that after migration check is done, you go just round and round in a circle, because you're done with one migration wave, you can check the box, but then the next migration wave comes, and the actual process of that migration is a pretty long process, typically, depending on how many VMs and how many applications you have, of course, but still, typically it takes a couple months before that migration is actually done. So all of those steps that I mentioned earlier, you just go back to step number 1, making sure that all of those migration waves are still as isolated as they can be, because application landscapes may change during those months when you are migrating them. So just make sure that you have every single thing in order before you hit the migrate button on the next migration wave. All right, now let's have a look at the features within vRealize Network Insight and vRealize Operations that make that migration planning possible. First off, let's start with vRealize Network Insight and look at the application discovery, the first step that you're doing. So if I go to applications over here from the main page, I first get a view of all of the applications that are currently in the system. So you can open up the application dashboard to get the information on an application level. You can see the amount of tiers and the amount of members. You can also see that there's a makeup of VMs, physical IP addresses, or even Kubernetes services. But I want to discover these applications before. So there's a couple of ways you can do this. You can do it based on a tag. You can do it based on pulling down the application information from ServiceNow, the CMDB. You can use a naming convention. So if the application name or the tier name is inside the VM name, you can pull that out. But you can also mix and match them, and even including security group name. So if the application name is in the security group name, you can pull that out of there as well. But the ideal situation is the flow-based application, where we can discover based on a specific cluster or the entire environment, and then also figure out the naming convention. So in this case, it will look at the VM names for the application names. And it just focuses on network traffic that goes through your environment, right? So you install vRealize Network Insight, you make sure that your vCenter is added, and get the NetFlow, get the IP fix from the vSphere distributed switch. And then it'll figure it out, correlate the network traffic flows against the VMs, and then it's able to do that application discovery based on those traffic flows that go through the network. So the result, for instance, of one of these applications is this on-prem Imagic VM. We are very confident that this application is correct and that it's not missing any tiers or any VMs. And we have this database VM right here. And then we also have an application tier where we can see 2 applications, VMs inside that tier. And this really seems like that specific application is very correct. So we can save this to the system. It will save the tiers. You can even rename them. So if you just want to be brief, you can do this. You can also change the name of the actual application first before you save it. But in this case, I've already saved this application and I've got multiple of these applications that I can work with, so I'm not going to save it. But basically, this is just a very quick list of what type of applications are in my environment, right? So once you've saved these applications, you can start doing that dependency mapping thing. I'm going to show you that in one of my pinboards that I created. And this is a network migration planning pinboard where I've grouped on a specific network. So again, I've been talking about applications and VMs and all of that, but There's also that per network migration scenario where you can pull up a specific VLAN and then start migrating on a per VLAN basis. So this information is grouped on that network. It could easily be as grouped on that application, but again, I'm showing you that as a network. So that application dependency mapping, or dependency mapper, I should say, is this donut. So in this case, we can group by VLAN, VXLAN, or overlay, just so a network. And then we can select or see the communication from that group towards other either VLANs or the internet, for example. And if I click on this slice, I can actually see all of the flows that are flowing from VLAN 10 towards the internet. Luckily, there is no incoming connection, so this is not an interface network internet-facing network, so there's no incoming net rules or whatever. And we even have recommended file rules here, and this is a very straightforward one. We're just using NTP and some HTTP web services. And we can export these as CSV and then import them into the firewall itself. So this is on this specific line, this communication. So I can also open up this entire network and then look at the recommended file rules over there, because that would be a lot more. Like there's a lot more services going through that entire network. So if I look at the recommended file rules based on the network itself, you can see also the inter VLAN connectivity, and we have those recommended file rules right here for you. So if I scroll down a little bit further or look at these numbers first, we have a summary of all of the traffic that goes through this network. We have the north-south incoming and outgoing, so internet traffic incoming and outgoing, intra-network. So within that network and the internet traffic, well, as you can see, not a lot of internet traffic. And then the average rate and the maximum rates. So average is very, very little. And then the spikes are also not that much in this case, but at least you know what those numbers are. So you can scope the data center interconnect based off of that. The cool part is that you can also see what VMs are all in the network within one view. You can also see how much traffic those VMs are consuming and sending, and even dive into the actual flows. So this is just an overview of what VMs and what are the top talkers within that network, so you know what is there. That per country view that I mentioned, so if it's an internet-facing application or network, you can determine where to put it in the public cloud. And again, not much internet traffic over here. And basically what happens with that dependency mapping is that you first have one of these views where you have a lot more dependencies. So if I hover over this one, you can see the top video application has a lot of communication with a lot of other applications. And if I keep focus over here, then I can see that towards the CMM records, the connectivity is one way because there's an arrow over here. And then the DNS servers are both being connected from the top video, but also the DNS servers are also connecting to the top video server for some reason. And if I wanted to know why, I could dive into the actual flows and see what's going on over there. So this is the dependency view. You can group all of these applications based on those dependencies and then get those migration waves. You can also dive in much deeper and look at it on a per VM basis and have the exact same view on a per VM basis. Right, so when you are migrating, so when you are monitoring the migration while it's happening, there's a couple of things that we need to take into account when it comes to network monitoring. One of them is the latency between data centers. So if you're migrating between, let's say, AWS on VMware Cloud on AWS and an on-prem environment, so you're evacuating your data centers towards VMC and AWS, you need to take that latency from your on-prem towards AWS into account. So you can monitor this. You can also set alerts if it spikes too high, and then you can investigate why that is. The VMware HCX layer 2 extension appliances are monitored here as well. So you can see how much traffic is going through my network extensions that I need to put in place for those migrations to facilitate not having to re-IP them. And again, you can set alerts. I will show you a little something else where that becomes clear. And even if I'm looking at it from the network point of view, vRealize can see which VMs and which applications are still on-prem, and then which ones are on VMC and AWS or the destination side. So you have a to-do list and a done list, basically. And then lastly, if there are any problems with flows between the destination cloud and the on-prem cloud, you can troubleshoot that on a individual flow basis. So you can see which VMs are going over those layer 2 extensions, what is the port number, what is the traffic pattern, behavior, etc. And then lastly, you can put those alerts on those HCX network extension appliances to make sure that doesn't go over a specific threshold. And in this case, it's not going over the red square, so it's not going over that threshold, so it's not generating any alerts. But you can see all of the layer 2 extension appliances in one view, and then also seeing which ones are overloaded, which ones are loaded the most. And also even like if you want to monitor your direct connect interfaces, if they have any problems or not. And even if you're troubleshooting a specific flow, you can also pull up that network topology between your on-prem data center and the VMC and AWS environment in this case, and zoom in on all of the network rules, all of the physical devices that might be attached to it, the NSX components, and of course also the file rules on the source. So let's move on to vRealize operations, where we have two things that I want to show you. One of them is the right sizing, but first I want to go to the Whatif analysis. So in the planning stage, if you're looking for how much resource do I need on the other side, I can create a scenario. I like to migrate to AWS on VMware Cloud and AWS in Europe. I have to select either the standard or the quick one instance type. I can give a 10% slack space over here. I want to also have 10% headroom. And I want to import everything from an existing VM. And then I can select the application coming from vRealize. So this is where that synchronization comes into play. And then I just select all of the VMs within that migration wave. Okay. And then it'll take into account the resources of all of those VMs in those migration waves. And I can also override the utilization projection or even put in an annual growth projection. But in this case, I'm just going to run it cleanly. And this is going to take a while. So I've already opened up the result over here, where you can see this many VMs to be migrated, CPU, memory, disk space. How many hosts do I need in order to support this in VMC and AWS? What will be the used resources of those hosts? And what, maybe more importantly, what would be the cost of hosting this in VMC and AWS? I can drill down in a per CPU, memory, and disk space, what will be used and utilized within the environment. But at least I can see exactly how much utilization will be there, how much will it cost if it's a first migration. So just making sure that you have enough headroom for this entire migration. So it could be that you're doing this for the first time and then you need to deploy the first host. So in this case, I would deploy 4 hosts. But it also could land on a existing host's environment, right? So you could edit this, make sure that you select an existing environment, and then it'll add up the current utilization plus the expected utilization, so you know that you're not going over it. Okay, so the other thing that I wanted to show you is the right sizing, where we can look at specific environments. In this case, I'm looking at a logical data center. I can already see that I've got cost optimization of more than $1,000. And there are a lot of oversized VMs, but also undersized VMs, because those are also important. And I can actually just directly from this environment, I can select everything and then resize them, or I could also schedule that action. So if I want to do it in a maintenance window, but if I press this button right here, it'll shut down everything and resize the VMs based on the recommendation. So this comes from a capacity engine within vRealize operations, which calculates the required CPUs that this VM needs and the memory, but then also leaves in headroom for it to grow, so it doesn't get constrained right away. You can also configure that. But this is a very easy way to get rid of those extra resources before you migrate, or like I said, maybe after you've migrated because you're in a hurry. This will save you a ton of money when it comes on a monthly, and especially if you're migrating to the public cloud. So you want to make sure that you're not wasting any money over there. All right, so that was it for the quick demo.